Have you ever wondered if the future can influence the past? We're about to dive into a realm where the traditional linear perception of time is challenged, and the boundaries of causality are pushed to their limits. This is the world of quantum physics. In our everyday lives, we're familiar with the idea that cause precedes effect. If you knock over a glass of water, the consequence is an unfortunate spill. The cause and effect are clear, and they occur in a specific order. But quantum physics proposes a different story. A story where time's arrow might not be as straight as we think. The concept we're exploring today is called retrocausality. It's a mind-bending theory that suggests that cause and effect may not be strictly unidirectional. In other words, events that happen in the future could potentially influence or even shape events that occurred in the past. This idea might sound like science fiction, but it's a theory that has sparked serious discussions among physicists worldwide. It challenges our traditional understanding of time and space, and it opens up a world of possibilities that are as exciting as they are bewildering. So buckle up as we journey into this quantum world where time might not operate as we've always believed. What if I told you that the future might have a say in shaping the past? Welcome to the world of retrocausality, where the future can impact the past. Imagine, if you will, a world where the arrow of time doesn't just fly straight from the past to the future. Instead, it zigzags, loops, and sometimes even shoots backwards. Sounds like something out of a science fiction novel, doesn't it? But in the realm of quantum physics, this is a theory known as retrocausality. Now let's break it down. The term retrocausality is a portmanteau of retro, meaning backwards, and causality, which refers to the relationship between cause and effect. So, essentially, retrocausality is the idea that an effect can occur before its cause. It's like baking a cake before you even decided to make one, or feeling the pain from a stubbed toe before the unfortunate meeting of your foot and the furniture. This concept, of course, challenges our conventional understanding of time and causality. We're accustomed to a world where causes always precede effects, where actions have consequences, and where time moves in one direction, from the past through the present and into the future. Retrocausality, however, suggests that this might not always be the case, at least not in the quantum world. But why does this matter? Well, if retrocausality is a genuine feature of our universe, it could fundamentally change our understanding of how the world works. It flips the script on cause and effect, and asks us to consider the possibility that the future can influence the past. It's a bit like a detective story, where the ending is known, but the events leading up to it are a mystery. In this case, the ending is the present, and the mystery is how the past was influenced by the future. Sounds mind-boggling, right? Let's dive deeper. To understand retrocausality, we need to examine John Wheeler's experiment. This groundbreaking venture is a bit like a science fiction plot, but it's firmly rooted in the realm of quantum physics. John Wheeler, a renowned physicist, proposed an experiment that's now famously known as the delayed choice experiment. Imagine a photon, which is a particle of light, being shot towards a screen with two slits. Now, the photon can pass through either one of the slits, or, strangely enough, through both at the same time. This phenomenon is known as superposition, a fundamental concept in quantum physics. But here's where things get even weirder. After the photon passes through the slits, an observer makes a choice. The observer decides whether to measure the photon's trajectory or not. If the observer measures the photon, it collapses from superposition to a definite state, passing through only one slit. If the observer doesn't measure, the photon seemingly passes through both slits simultaneously. So far, so good. But what does this have to do with retrocausality? Well, Wheeler suggested that the observer's choice in the present could influence how the photon behaved in the past. In other words, the decision to measure or not measure the photon's trajectory can affect whether it passed through one slit or both slits, even though this choice is made after the photon has already passed through. This proposition seems to defy our everyday understanding of cause and effect. But in the quantum realm, our everyday rules don't always apply. This idea of retrocausality, where the future can influence the past, is not universally accepted. Yet it's a theory that has been gaining traction and has been published in various scientific journals. The delayed choice experiment and its implications continue to be a subject of intense debate and research among physicists. John Wheeler's experiment is a testament to the paradoxical nature of quantum physics. It challenges our understanding of time and causality, suggesting that the universe might be a lot stranger than we ever imagined. This experiment gives us a glimpse into the paradoxical world of quantum physics. The mysteries of the quantum world continue to confound and intrigue us, prompting us to question the very fabric of reality. And who knows, understanding these quantum oddities might someday change the way we perceive the world. Retrocausality isn't just a fascinating idea, it has profound implications. This theory, as mind-bending as it may seem, is more than just a theoretical curiosity. It could potentially reshape our understanding of the world and how we perceive the nature of time and causality. Let's start with the realm of quantum physics. This field, known for its complex concepts and puzzling paradoxes, might be the first to benefit from retrocausality. One of the most perplexing aspects of quantum physics is quantum entanglement, a phenomenon where particles become interconnected in such a way that the state of one instantaneously affects the state of the other, no matter the distance. This spooky action at a distance, as Einstein famously called it, has been a source of much debate. Could retrocausality provide a solution to this mystery? Some researchers believe so. In the realm of retrocausality, the future state of the particle could influence its past, which might explain the instantaneous correlation we observe. This implies that time, as we understand it, may not be as linear as we perceive. In the quantum world, past, present, and future may be intricately interconnected in ways we are yet to fully comprehend. Beyond quantum physics, the implications of retrocausality could be far-reaching. If the future can indeed influence the past, it could revolutionize our understanding of cause and effect, a fundamental concept that underpins our understanding of the physical world. Of course, these ideas are still very much in the realm of theory. But as we continue to probe the strange and wonderful world of quantum physics, theories like retrocausality provide us with new ways of thinking, new perspectives, and potential solutions to some of the greatest mysteries of our universe. In conclusion, retrocausality is more than just an intriguing concept. It's a testament to the endless possibilities that the study of quantum physics can uncover. As we delve deeper into the quantum realm, who knows what other fascinating ideas we might stumble upon? The future affecting the past might not be just a fantasy after all. Retrocausality is more than a theory. It's a potential game-changer in quantum physics. As we delve deeper into the world of quantum mechanics, the idea of retrocausality is becoming increasingly prominent. This isn't just an abstract concept to ponder over a cup of coffee. It's a working hypothesis that's drawing the attention of researchers around the globe. Why is there such a buzz around retrocausality? Well, it's because this theory has the potential to radically revolutionize our understanding of the world. It's not just about photons and slits. It's about redefining our very understanding of cause and effect, of time itself. If the future can indeed influence the past, as retrocausality suggests, then our linear perception of time might need a serious rethink. But let's bring this back down to the quantum level for a moment. Quantum physics has always been a field ripe with mysteries and unanswered questions. And retrocausality might just hold the key to unlocking some of those enigmas. By exploring how future events can influence past behavior, researchers are hoping to gain new insights into the strange and often counterintuitive world of quantum particles. This is not a journey for the faint-hearted. It's a quest that challenges our fundamental assumptions, that pushes us to think outside the box. But the potential rewards are immense. If we can harness the power of retrocausality, we might be able to advance our knowledge in the field of quantum physics in ways we can't yet fully comprehend. So here we stand, at the edge of a new frontier in quantum physics. The journey ahead is filled with uncertainty and intrigue, but also with the promise of discovery. As we continue to explore the concept of retrocausality, we are not just probing the nature of time and reality, but we're also venturing into uncharted territories of human understanding. Who knows? In the world of quantum physics, the future might indeed be reaching back to shape the past.